I'm representing XKDR Forum. We are an economics research think tank in India. We were users of R for the longest time, and then we saw Turing.jl, and then we thought we must shift to Julia. So then we shifted to Julia. So we shifted around 2020 August. But we found that a lot of the basic things were lacking. So we found, for instance, in lowest.jl, you could not put more predictors, more predictors. And in GLM, we found you could not do QRD composition. So we started fiddling with those things. We started doing some PRs, and then we got a project from the Julia lab to develop these things. So we are developing 4 packages, which are widely used in R. And we're also doing PRs and improvements in terms of issues to existing Julia packages, such as GLM, hypothesis tests, distributions, anything under the hood. So today there are 4 talks, one by myself on Survey. So Survey is a widely used R package. Then there is one more by Bogomil on GLM. So he's not in our team, but we've been collaborating a lot together on GLM and various other things. So the other live talk today is by Bogomil, and then there are 2 recorded talks. There's one more on GLM, because we think in statistics, it's one of the most important things. So there's one more on GLM, and then there is one more on regression, but this one is more on the Bayesian side. So we're building a package like Zelig, which is in R, and then we're using Turing, GLM, and other things as the dependencies. So I'll start with Survey.jl, and then we'll move to Bogomil's talk. His talk is on using GLM in econometrics. So he took the standard book, Jeffrey Wooldridge book, and then he basically solved that using GLM.jl, and then he discusses the things that are lacking and that are there and what can be improved. Right? Yeah. One more thing that I want to add, that we are also trying to promote Julia in India. We are taking a lot of students as interns and trying to mentor them. We are also doing meetups, so we're also in that process. So other than just the packages, we're also thinking just generally about Julia and how to have it more in India. So I'll just briefly describe the problem statement. So suppose you want the average height of Americans. You can go and measure everyone's height and then take the average. But that's obviously not feasible. So you take a small sample. You take 100 people at random or something, and then take the average. But that number won't be perfect. It would be an estimate. And that estimate would have a margin of error. So this package is about finding out that margin of error. Surveys can be a little more complicated, because if you take 100 people at random in America, then you'd be hopping from Alaska to Florida and so on. So that's not going to be cost effective. So what you end up doing is that you select some places at random, and then you go there, and then within those places, you select some people at random. So there are these complications. And this package is about, given that these complications, how do you compute the margin of error? We're going to use variance, standard error, margin of error, interchangeably, confidence interval. They're not the same thing, but they are calculated from one another. So you need functions and algorithms that are specifically made for surveys to deal with these complications. These functionality are there in other languages, such as R, Stata, SAS, and so on. We've been using the package in R by Professor Thomas Lumley, and it's been, so he's part of the R core team, and it's been developed for the past 2 decades. So it's a stable package, and we've been using that for the past 5 years. Now, surveys are becoming larger because you can do telephone surveys, you can take internet surveys, so so you need a more efficient computing framework, and that's why we thought of this being a good place to, so Julia would have a good role in this, I think. Yeah. So we are committed to the development of the package because we are using it ourselves, right? We are analyzing household data for our economics research. And that means that we will be developing this package in the long run. So a lot of Julia packages, I feel they start and then they, it's like a pet project for somebody, and then they, it doesn't end up going. And we feel if there is some application that the developer has, then it's more likely that the package would keep developing. So that's why we've chosen to put our resources in Survey.jl, while there are so many other options that we could have started with. But this is something that we are using. And yeah, that's why we think the development will keep going on. The second thing is that we have been long users of the R package, so we know the ins and outs. And the way we are developing is we are testing everything against the R package. So if you do a PR and the answers don't match with R, then we don't accept that PR. So you can assume that all the answers are correct because they're all, I mean, if the R package is correct, and the R itself was tested against data and so on. So if somebody made a mistake like 30 years ago, then we will have the same thing. But otherwise, you can assume that the stats is correct because it's been matched by other systems. Okay, so we want the data to be in a data frame. And then all the underlying operations that we have, like group by and combine, they all use the data frames API. So we want the underlying system to be data frames. So the general workflow is that you have some SQL server, and then you pass that into a data frame using DB interface. And then from there, you make, from there you use the survey package. Alternatively, you can have a CSV file, and then we were discussing for the past few days about Arrow and other systems. So for playing around, there are some toy examples with the package. So you can use something like load data Nahans, and then that would load the Nahans data, which is small survey data included with the package. These are used for tests and also for documentation. You can test out the documentation using these data sets. Okay. So with the data set, if you pass information about clustering and stratification weights, the complexities of surveys that I had earlier mentioned, then you make a survey design, and then you use that, you use all the estimators on that design. So there are certain features, so the data is there, and then there's some other information that you need to give. And then from there, you construct a survey design. So here's an example. Suppose you have a simple random sample. So something like I described earlier, if you selected 100 people in America at random, so there you just have that data. So we have a sample data set for a simple random sample. It's called API SRS, and then you can make a survey design from there. Now, suppose you have a stratified sample. So a stratification is, you can think of it as if you were to sample each state of America differently, so then your state would be the stratification or the strata, and then you can pass that information in the survey design constructor. Similarly with clustering, if you have clusters, so I had given the example that you pick some cities at random, so then those cities are your clusters. Then you can pass that information. Then there are multi-stage. I won't go much into this because this has not been implemented. So you can have the constructor, but all the algorithms approximated to just single stage. And then you can have both stratification and clustering, so you can pass both that information. Here's a real-world example where there's both stratification and clustering. And this is actually the data we use at XKDR. So yeah, we use DB interface, and then we pass that to a data frame. And then from there, we make a survey design. Okay, so I also want to use this opportunity to discuss the internals. Internally, if there's only one constructor, so if you don't pass strata, then it'll make a strata column. If you don't pass clusters, then it'll make a clusters column. And this just makes the this just makes our life easier from a developer's perspective, that we just have some functions that work on everything instead of separate functions for each kind of case. So you can do various estimations. So for example, I told you about the average height of people. So that's a mean, and then you can do median, total, quantile, and so on. You can also do multivariate estimations such as ratio, regression, and then so on. There's also domain estimation. So sometimes you may want, let's say, the average height by a state. So that by is a domain. So you often want that, and that really complicates things often. So suppose you have a survey design, then you just call your estimator. In this case, it's just mean and quantile. So you just tell your column, and then your survey design, it gives you the mean. In this case, it automatically computes the weighted mean and weighted quantile. You can also do GLM, so you pass your design, and then you pass your formula, and you can do ratio also, but these are currently being implemented. I talked about domain estimation, so you can have a domain. In this case, I just did it with S type, and then for each S type, you'll have the mean. Now coming to the heart of the problem, the variance estimation, or the estimation of the margin of error. So many packages such as GLM give you the standard error, but they don't take into account the complexities of the survey design. And that's what this package is about. This is what the R package, the Stata, and then so on are about, that you use the sampling design in the calculation of the standard error. And there are two ways of doing this. So one is called Taylor linearization. We have not implemented this in the package. The other is resampling. So you simulate your survey using the survey design. And then for each of the simulation, you find out your estimator. And then from there, you find out the variance. And this is where Julia is a lot faster than R. We found that for most of these simulation techniques, it's about 10 times faster. You can think of it as, for the same amount of time, you can do 10 times more samples of your simulation. There are some standard techniques of doing this simulation. So one is bootstrapping. This is not deterministic, but it's the best approach. Then you have jackknife, which is deterministic, but it's a bit biased, and then some other ones that we haven't implemented. So you can use this function called bootweights to create a replicate design, and then it uses this formula for weights to create the replicate design. But notice that it added additional columns in your data frame. So if you made 1,000 replicates, then it adds 1,000 columns in your data frame, and it modifies your original data frame. Using these columns, then it computes the variance using a formula. So if you pass the replicate design instead of the survey design, and in addition to the estimate, it also gives the standard error. Similarly, you can do it with jackknife. You pass your survey design, and then it makes a replicate design of type jackknife, and then it can calculate the variance using this formula. So if you pass a replicate design instead of a survey design, then it gives you the standard error in addition to the point estimate. Internally, it's not just for mean and total and some simple functions. You can do it for any function. So there is a variance function, and you can pass any kind of function into that, and it would compute the variance for that estimator. This is the same way it's been done in R also. So just about what we are trying to do from here and in the future, we'll do we'll port everything from the R survey package, and then we'll try to integrate the cutting edge features like Turing. So for instance, you have prior for the mean or the parameter of the mean. So you want to be able to integrate that with survey. right now, the way to do it is you do bootstrap on top of MCMC, but that's too costly. So we're trying to find a trick, but even that is much faster in Julia. MCMC is faster and bootstrap is faster. So compared to R, you'll be a lot faster if you use this. So finally, there have been 3 main contributors. There are 2 Google Summer of Code students that have worked on this. There have been numerous volunteers who have done PRs. So there are many people who I don't know, who have just done PRs to the package, and there are some people who we've had good discussions with, and yeah, we acknowledge the support of MIT and Julia Lab for financially supporting the project. That's all. Okay, any questions regarding this or XKDR or what we're trying to do? Anything? Yeah.
This is fantastic. So you considered the Lumley's survey package.
Yeah.
Now, is there a procedure where we can use factor analysis in Survey.jl?
Not right now, but the idea is something like this. Yeah.
Yeah. So what function does that in Survey.jl?
So right now the Lumley's package is just like a base package for survey, and then there are like 50 packages built on top of that. So I imagine one of those packages would be doing that. I'm not very familiar with factor analysis, but the core functionality is what we're trying to do right now. And then later on, we can do all the other packages built on top of Lumley's survey. So for example, like inequality packages built on top of survey, and there are 50 other packages. But at the core, this is what the package is. Just you pass any arbitrary function, and then it gives you the variance for that.
So at the moment, it does weighted sampling.
Yeah. Yeah. Yeah.
Very naive question. Could you just briefly go over the difference between clusters and strata again?
Yeah. So strata, so suppose you sample 100 people in America, then it's possible that you underrepresent certain regions, right? Let's say by chance you don't get anyone in Florida, right? So just to avoid that, you can divide your population into groups, so you can have state-wise divisions, and then for each of those states, you do sampling independently. So you can out of time fix that. I'll pick 10 people from Florida, right? So you're sure that you're not undersampling it. So that's stratification. But so these are independent. So then Florida is independent of, let's say, California, right? Clustering is, suppose we have these groups, suppose we have these states, and then I pick some states at random, and then I sample all the people in the states. So actually, a better example of clustering would be if, let's say, you were testing light bulbs, right? So you want to find the defect rates of light bulbs, and then your light bulbs are in boxes. So if you do a random sample, so if you just had the list of light bulbs and if you just did a random sample, then you would end up opening a lot of boxes, right? So what you do is you select some boxes at random, and then if you've opened a box, then you might as well sample all the bulbs, right? So that's the idea of clustering, that once you go in a place, then you sample all the entities in it, because once you're in a state or once you've opened a box of bulbs, then you might as well take all the samples. So that's the difference.